Welcome to COM5013 or 5013 if you prefer. My name's Dr. Nicholas Day, call me Nick, and I am the module leader. So it is my delight to welcome you to the module. I hope you're going to enjoy it. There's a lot of fascinating problems, a lot of real life scenarios that we're going to explore during this module. And we're going to see that algorithms and data structures are all around us. Once you start noticing them, you'll start seeing them everywhere. I can assure you of that. And what we're going to explore in this module is that there isn't a predefined best solution to a particular problem. So if you're working on like a scheduling problem, well, there could be multiple optimal flow algorithms, there could be multiple pathfinding algorithms, there could be multiple sorting and searching algorithms to find your target value, whatever that is, your response or the end goal, whatever that is you're trying to find. There isn't no one best solution for it. It depends upon a number of different factors. So we're going to explore how these data structures and algorithms respond to those different factors so that you can choose the optimal solution for the scenario. Okay, so that's what we're intending to do in our module, and we're going to explore a number of different real life scenarios so you can see how what we do relates to the real world. Okay, and let me show you this. This is our Big O chart. We're going to be referring to this quite a lot. This is just a mathematical classification for how we can determine the performance of our algorithms measured in classifications or categories rather than continuous values, because they will change, they will vary depending on hardware, depending on software. Okay, so we're going to measure more in terms of classification rather than continuous values. So we'll have a look at how we can classify algorithms in terms of their runtime performance and space complexity as well that they use. Okay, so we'll be seeing a lot more of this chart, a lot more of these terms. O of 1, constant time, O of log n, logarithmic time, O of n, linear time, n log n, linear-arithmic, quasi-logarithmic, quadratic, O of n squared, and there's others, factorial, exponential, etc., polynomial too. So we'll be exploring a lot of that. Let me tell you where this module sits. Well, here we are. We are extending, we're building on top of the Python basics. Okay, so I will we'll spend the first few sessions just warming up, just recapping and refreshing our memories on the basics of Python that we explored in COM5008, 4008, Programming Concepts, our intro to Python. Recap all the basics, conditionals, functions, object-oriented programming, the inbuilt data structures that we get with Python, lists, tuples, dictionaries, sets, okay, and then we'll build on that by having a look at a number of different algorithms and data structures and how we can write them in Python. Okay, so that's our sort of software engineering, computer science pathway from level 4, and you can obviously then go on from this module to take design patterns, which is presently in Python, and we'll extend what we're doing here even further. We look at typical solutions, predefined patterns, predefined solutions in software architecture that you can then integrate with all the different data structures and algorithms that you're seeing in this module. Okay, so as it's a step up, as this is a level 5 module, I will push you a bit harder. The exercises are designed to push you a bit harder. They're formative, most of them, so they're for your development, to stretch you, to grow your programming muscles, to exercise you. Okay, so the more exercise you get, the more better performance you have. Okay, so that's the idea, is to exercise continuously and constantly so that you can keep growing and keep progressing. So that's what these formative exercises are designed to do. Okay, so we're on this pathway. But you might also be on the AI pathway as well. You may take machine learning and then deep learning, as well as computer vision and image analysis. That's you probably interface with a few different things that we use in this module, NumPy. There's lots of other EDA and matrix related modules that we sometimes import into this module, but that's has a particular focus with data. We have a little bit of an interface with data, but we're more interested in sorting and searching rather than extracting insights and correlations, analyses of that data. Okay, so just to let you know, the two pathways And there we are. All right, so let's have a look at what we're going to do in this module, COM5013 or 5013. As mentioned, we'll start by warming up. That's our first 2 sessions, doing all the Python basics from the last year, the last module, level 4. Then we'll contrast the NumPy arrays, which are technically different from the Python lists, so I'll tell you all about that. They're both indexed structures, so we'll compare those indexed structures. Nice and efficient. We can go straight to any given point in that structure, just using the index. Go to position 7, go to position 10, go to position 15, all in constant time. Not so in referenced structures, where there aren't indices, like linked lists, where they are linked together. The objects are chained together. They are referencing each other. So you have to start somewhere and iterate through the list to find what you're looking for. So that has performance advantages. It also has performance disadvantages. So we'll compare those as we go. I'll talk more about big O notation in asymptotic complexity. That's just a fancy word for measuring complexity and formalizing it in terms of mathematical notation. So we'll look at that, and then we'll apply those to sorting and searching algorithms, so you can time them and look at the number of operations performed, run on a whole different variety of different circumstances. Okay, we'll have a look at stacks and queues, which model real-life phenomenon, a real-life queue. You know, imagine queuing up to get a coffee in the morning, or queuing to get the bus, queuing to get on the aeroplane. So we'll have a look at those principles: a stack of plates, a stack of orders, a stack of papers. We'll have a look at how those structures, how that arrangement of data affects the overall performance. A heap, so that's a throwback to how we store data. The stack would typically be a smaller data store, and a heap would be just like, think of like a heap of clothes. You know, if you get all the clothes out your washing machine, it's just a giant heap, isn't it? Or in a big bundle of them. So we have to kind of sort through where are they, and that's the kind of the metaphor here with a heap. Heap is a larger data store. Things are just thrown on it, so we have to look at things like heap sort to be able to sort our heaps, so we can actually navigate them easily. They map to trees, so we'll have a good look at that too. We'll have a look at hashings, have a look at how we convert string-related data, more data with semantic meaning, names, nouns and things, of places, people, we'll map them to unique integer positions. There are problems with that, of course, that translation between numbers and characters. So we'll have a look at collisions, how we resolve those. There's 2 different main schools of thought there, open and closed. So we'll explore the differences between those 2 different ways, open addressing, closed chaining. So explore those. Have a look at how we can apply the hashing principle, which generates this huge long string of hexadecimal values if you're using RSA or SHA, secure hashing algorithm. Have a look at how that is applied in situ, how that applies to current technologies such as the blockchain, how all the items in the ledger are chained together, bringing together linked lists and unique hash codes. So we'll explore that. That's a fascinating lecture. Have a look at trees, so how we have branches of nodes, throw back to linked lists, how we search through them, whether we do breadth first search, the breadth of the tree, or whether we do the depth of the tree. Okay, so we'll contrast those different algorithms. It's a classic search problem, breadth first search versus depth first search. We'll explore that. And then graphs are slightly different to trees. They're node-based, they're reference-based. But they're more concerned about modeling distance, or in networks it might be the capacity between nodes rather than the arrangement of said nodes in trees. Okay, and that maps to pathfinding if you're using graphs, because you have to navigate your way through a network, through a graph of nodes. So explore all different pathfinding algorithms. Dijkstra's is a famous algorithm. There are many, so we'll explore those in those 2 lectures, and then finish up with things like dynamic programming. I don't know if any of you did decision mathematics or not. I think you'd have to have done further maths to do D1 and D2, but it's a fascinating module, so I'll introduce you to the key points from that. Richard Bellman's principle of optimality. There's also the Bellman-Ford algorithm, so we'll have a look at that, and of course we'll apply it to many of the different themes that we've seen so far. So dynamic programming is a whole style of programming. There's also things like greedy algorithms as well. Dijkstra's could be considered a greedy algorithm, so we'll contrast the different programming styles as we come into land for the module. Okay, so yeah, there we go. That's a little introduction to what we aim to do. Let me just tell you about the learning outcomes. I think we'll record a separate video for assignment brief, so I'll tell you all the ins and outs with your assignment, but essentially it's an open choice assignment. You get to choose a scenario or a situation, a particular application that models the use of data structures and algorithms. It will ask you to implement once you've chosen and justified your choice of data structures and algorithms for that particular scenario. So that comes back to what I was saying right at the start of this introduction. There's no one best solution. You have to weigh up all the different environmental factors to work out which algorithms and which data structures are better suited to what you're trying to do. So that's what the whole assignment is about, and hence reflected in the learning outcomes as well. What we're trying to achieve, we're trying to help you, learning outcome 1, to identify the performance of algorithms when they're run. That plays into the evaluation of them. This is all big O, essentially. We're looking how to identify their performance in terms of big O, and for you to then weigh up, which case are they better suited for, which are they more appropriate for, when it comes to your brief. And then of course, once you've chosen them, then to actually code them, to implement them, to test them in a given language. It's worth saying all the materials are in Python for this language, module, but you can easily take a data structures and algorithms course in C++, in Java, in any given object-oriented language, because these are just concepts. We're looking at how they apply. In Python, you may want to do in a different language if you're more comfortable in that, but just letting you know, because we are continuing level 4, these materials are extending what we did in level 4, so they're based in Python. Okay, so we'll talk more about the assignment, all the ins and outs, all the marking criteria a little bit later in the module, but just to let you know, that's how we're going to lay out and format the module. Okay, for this particular run of it in term 1, so starting out with a warm-up, and then we're going to group by theme. So have a look at the difference between indexed and reference structures, look at how we classify algorithms, stacks, queues and heaps, hashing, trees, graphs, and then dynamic programming to finish. And then we'll kind of have some workshops and wrap up. Maybe I'll bring some mock interview questions, because this is the sort of standard if you're going for tech-heavy roles, developer roles for big companies and big organizations. They like to give you lots of very taxing and challenging algorithmic questions. So it's good for you to train your brain to get used to these types of questions, just in case you end up getting one in an interview, just so you can think your way through it, okay? It's not always necessarily about getting the correct answer, because employers might be more interested in how you think rather than whether you have a predefined solution. And indeed, if you explain as you go, if you make a wrong turn, at least they can go back and say, well, at this juncture, if you pursued this path rather than that path, you would have then probably went on to get the right answer. So that's why it's really important that we exercise our brains. And indeed, that's exactly what these exercises, all the formative exercises I'm going to give you throughout these lectures, are intended to do, okay? So they will stretch you, they will push you, they will challenge you, I'll warn you now, okay? They are definitely a step up from level 4, but it is for your benefits that you are stretched further, so that you grow, so that you learn, and so that you make progress. Okay, so I come into land here, just wanted to say hi and just wanted to tell you about the module. So I look forward to seeing you in the first session.